To continue our discussion about conic sections, and we are going to talk about ellipses. So pretty similar learning goals to what we had with parabolas and circles. We want to be able to graph ellipses and hyperbolas from given equations or characteristics, and we want to be able to write equations for ellipses and hyperbolas given the characteristics. So we should probably know what these generally look like. So these are the standard form equations for ellipses and hyperbolas that are centered at the origin. And remember that eventually they're not all going to be centered at the origin. But for now, it's an ellipse if you have x and y are both squared, and you've got basically when you divide, because you don't always have the fraction form, and you'll see that with the examples. This doesn't look like it's in fraction form, but if you divide by whatever the constant is, you'll get it equal to 1, and you've got an a squared and a b squared, so a denominator under each of those. If what is between those is addition, it's going to be an ellipse. If it is subtraction, it is going to be a hyperbola. So when we are looking at the ellipse, an ellipse, you should know what the shape ellipse looks like. But the characteristics that we are going to be looking for are obviously the center, which here is the origin, so 0, 0. Then we are going to be looking at what are called vertices and covertices. Whichever has the bigger denominator is going to be our a. So that's how you tell the difference between these two, because they look, well, they're the same. One has x with a and one has y with a. Whichever denominator is bigger, that is what we are going to call our major axis. So whatever a's variable is going to be our major axis. A is always bigger than b in ellipses. So we're going to have vertices and covertices. We're also going to have foci, so instead of just a single focus, and I've heard it pronounced foci too, so I'm not sure if it really matters or not, foci or foci. We're going to have those as well. You find the foci or foci by using the equation c squared equals a squared minus b squared. So obviously a squared and b squared are part of your original equation, so you use those to find your foci, because the foci are going to be located on these ones where we're centered at the origin. They're going to be on c away from the origin, so plus or minus c 0 in this case. So since a is always bigger, we say the major axis is the one with a. So here the major axis is the x-axis, which means this one is what we call a horizontal ellipse, because the x-axis, the x, is going to be longer than the y. So wherever a is, let's say this is a0, and obviously equally spaced, this is opposite of a0. Those would be my vertices. My covertices are not going to be as far from the origin as a is. Now they might be close, but because a squared is bigger than b squared, a is going to be farther away. So this is our minor axis, and we're going to make these 0, b, and 0 opposite of b. So this ellipse is horizontal. The foci are always on your major axis, so wherever c ends up being, this would be opposite of c0, and equally spaced, this would be c0. The second one, everything is the same except that this one is going to be vertical. So we're still going to be looking at vertices. So here the vertices were at plus and minus a, 0. The co-vertices were at 0, plus and minus b. Here, because it's vertical, it still has a center at 0, 0. But because it goes up and down, that means that our vertices, instead of being plus and minus a, 0, are now at 0, plus and minus a. Our co-vertices, likewise, are now at plus and minus b, 0. And our foci are going to be at 0, plus and minus c. So vertical just means it's going to be longer this way than it is this way. So this would be B0, opposite of B0. This will be 0, negative A, 0A. And then again, wherever C ends up being there, there's 0C. And the same distance away should be 0, opposite of C. So here is my lovely, that's rough looking, sorry about that. There's my ellipse. Now, standard form equations for hyperbolas look very, very similar. Here are the two differences: subtraction in the middle, and also the location of A and B. In hyperbolas, A always comes first. So it's not necessarily A is always bigger. A always comes first on hyperbolas. So A is always first. Whichever variable is first tells you which axis your vertices are going to be on. So because x is first here, my verticals are going to be on the horizontal axis. Here, because y comes first, my vertices are going to be on the vertical axis. So here, my key points, obviously I'm going to have a center, which is going to be at 0, 0. I'm going to have vertices, which in this case are going to be at plus and minus a, 0. Over here, my vertices are going to be at 0, plus and minus a, because it's going up and down. Then you're going to have asymptotes. Asymptotes are going to control how wide the branches of your hyperbola are. And when it's horizontal, the asymptotes are going to have an equation of y equals plus and minus b over ax. Over here, they're going to be y equals plus and minus a over bx. Now, I, under no circumstances, want you to try to memorize which ones are A and which ones are B. What I want you to know, this is a line. These are lines. This, B over A and A over B, is the slope. Remember that slope is always rise over run. So it's y value over the x value. So if you look at the number that's underneath the y, that's the one that goes on top. So here the B is underneath the y, so it was on top. Here A is underneath y, so it goes on top. Then you're also going to have foci here. Different equation though. Here c squared equals a squared minus b squared. Here your foci look just like the Pythagorean theorem. C squared equals a squared plus b squared. So in this case, your foci, because it's horizontal, are going to be at plus and minus c, 0. And over here, they're going to be at 0, plus and minus c. Now, what it looks like. You've got your center. You're going to have vertices. Wherever they end up being, they're evenly spaced. And then the asymptotes, they're just opposites of each other. So one has a negative slope, one has a positive. The asymptotes help you see how wide to draw the branches, but it's essentially just like two parabolas. Equally spaced. Your foci are going to be on the inside here. So on the up and down, same idea. You're going to have asymptotes, one positive and one negative. You're going to have vertices this time. They'll be on this side. Those vertices tell you how wide to make your branches. You never ever cross asymptotes, remember. And then you'll have foci on the inside. All right, so those are your general shapes and formulas. Now let's actually look at being able to graph them. So the first thing we need to do is put it in standard form. You are just simply going to divide by whatever the constant is once you've got x's and y's on the left and constants on the right. So I divide everything by 100 here. I get x squared over 25 plus y squared over 4 equals 1. So now I look at that, I say it's plus between, so I know this one is an ellipse. A is bigger, the bigger number, so that means a squared is 25, which means a is 5. B squared is 4, so B is 2. Now, because the x had the bigger squared value, that means that this one is going to be horizontal. So once I know A and B, I can plot my vertices and my co-vertices. So because A is 5, that means on the horizontal axis, I'm going to go 5 over each way. So plus and minus 5, 0. Your co-vertices, pen slipped there, are going to be at 0, plus and minus 2. And then my foci, you have to do a little bit of work for that. So I'm going to do c squared equals a squared minus b squared. So c squared is going to equal 25 minus 4, so 21, which means that c is the square root of 21. So my foci are going to be at plus and minus square root of 21, 0. So there's my information. I need to get all that information there first because I need to make sure that I have enough room, so if I need to change my scale, I can. The foci are going to be on the inside, so I know that my biggest value there is 5, so I should be able to fit all of it on here. So plus and minus 5, 0 would be right here and right here. 2 on the other axis. And then radical 21, it doesn't simplify, so we have to leave it like that, but you probably ought to know where that is. It's about 4.6, so your foci are about right here. Make sure that when you connect, I always see some people that accidentally connect the foci instead of the vertices. So there is my lovely ellipse. All right, let's look at the next one. Divide everything by the constant, so by 144, I've got x squared over 16 minus y squared over 9 equals 1. So I've got minus between, so this means that it's a hyperbola. Because the x is the first, that means that this is going to be on the horizontal axis. So horizontal hyperbola. So my vertices, oops, and I forgot to list the center on the other one. You know it's 0, 0, but because we will eventually be shifting, we need to get in the habit of making sure that we list it. So the center is here at 0, 0. Okay, so center 0, 0. My vertices, I need to find my A value here. So when I look here, my A is always first, so square root of 16 is 4. So plus and minus 4, 0 are going to be my vertices. My asymptotes, y equals plus or minus. Remember, it's always y value over x value. So square root of 9, which is 3, over square root of 16, which is 4. So 3/4 x. And then I need my foci. So c squared equals a squared plus b squared, so 16 plus 9. So c squared is going to equal 25, which means c is 5. So plus and minus 5, 0 are we putting those. So here is my info. Now I need to put it into action here. So center is at 0, 0. My vertices are at 4, 0 and negative 4, 0. So here are my vertices. My foci are just one more in. Remember that foci are always on the inside when we have parabola shapes, which a hyperbola is just like two parabolas there. So now I just need my asymptotes because that's going to tell me how wide it is. I don't have to find other points, I just have to know where my asymptotes are. So plus and minus 3/4 x, so that means up 3, right 4 from my center, and down 3, left 4 will give me this line. And down 3, right 4, up 3, left 4 gives me the other. Now, I want to show you on an actual example. The asymptotes make a box with the vertices and the center. So do you see here how it makes a little rectangle? So that should be helpful in making sure that you've plotted them correctly. So now I take my vertices and I can get the direction and width of my opening to not cross those asymptotes. So there is my hyperbola. All right, next one. Let's do some purple here. So we're going to divide everything by 128. So that's going to give me y squared over 64 minus x squared over 1 equals 1. So, because y squared is first, and this is subtraction, we know this is a hyperbola that is vertical. And a is going to be 8, b is going to be 1, because those are the square roots here. If I do c squared equals a squared plus b squared, I get c squared to be 65, which means that c is radical 65. So that should give me all the info I need. My center is at 0, 0. My vertices are going to be on the y-axis. So it's going to be 0 plus and minus 8. My foci are going to be at 0 plus and minus radical 65. And then my asymptotes, y equals plus or minus. The y was with the 64, so the 8 goes on top. So plus and minus 8 over 1, which is just 8x. All right, so obviously I'm going to need to count by something other than ones if I want to fit this on. So I'm going to count by 2's, and then I can plot away. So my vertices, plus and minus 8 right here. My asymptotes have a slope of 8, so that means from the center I make my box, so up 8, right 1. So right here, make sure you don't go 2. So down 8, left 1. Here we go. Then this way and this way. Remember, it makes a box. Now, hopefully you can turn your paper and connect this in a more neat way than I probably am going to. I can't turn this on my computer screen, so the best I can do is to try to connect such a steep line. Is very difficult to do without a straight edge. So sorry for the sloppiness. That is the best I can do. Now, can't see very well because it's so tiny, but the green is where your hyperbola branches are going to be. I still need my foci plotted there. So if you don't know approximately what the square root of 65 is, use your calculator to help you. It's a little bit more than 8. So your foci are just barely on the inside of those branches. And here is our important info. All right, divide everything by 16 on this last one. It's going to give me x squared over 1 plus y squared over 4 equals 1. So it's a plus, which means it's an ellipse. The bigger number is under the y, so this one is vertical. So my a is always the bigger number. Since a squared is 4, a is 2, b is going to be 1. C squared equals a squared minus b squared, so 3, which means c is the square root of 3. So I've got center at 0, 0. Vertices going to be my a, and this is vertical, so it's going to be on the y-axis, so 0 plus and minus 2. My co-vertices are going to be at plus and minus 1, 0. And then my foci are going to be on the same as my major axis, so 0 plus and minus radical 3. So important info. Now I just got to graph it. So let's see, center at 0, 0, vertices, 2 up and 2 down. Co-vertices, 1 to the right and 1 to the left. Here's the ellipse. And then I need my foci. Radical 3, if you aren't sure, check it, is a little less than 2. It's about 1.73, so 1.73 would be about right there, right next to those vertices on the major axis. All right, so we also need to be able to take this and write the equation. So first one in example 2, it says vertices and co-vertices, so that immediately tells you this is an ellipse. So vertices on the ellipse are your a values, so that means that a is 6, which means a squared is 36. Your co-vertices, that gives you your b, so b is 3, which means b squared is 9. Once you have that, you can right away know how you are supposed to write it, because this one, if the vertices are 0, 6, that means that the vertices are on the y-axis, so this is a vertical ellipse. So x squared over the smaller axis is 9, because the bigger one, if it's vertical, goes with the y, so y squared over 36 equals 1. Much easier than doing the graph. So much less that we have to do there. So there's that final answer. Here, vertices and asymptotes. So we know this is a hyperbola. The vertices are located on the x-axis, so that means that this is horizontal. Remember that when you've got, if it's horizontal, that means that the x squared goes first. So it's going to be x squared minus y squared equals 1. So I just need to figure out the denominators here. So I know here that this is my a value, and that corresponds with this down here. So that means my b value has to be 5. So here a squared is 2 squared, which is 4. And then 5 squared, which is 25. So that gives me my hyperbola's equation. All right, very important saying for today. If at first you don't succeed, then show your work. Always show your work.